All right, again on this one, we're just subbing in a billion for P, and then we're trying to solve this for Y, but the trick on this one is that this is actually already in millions. So like 770 there is the initial amount, but it's 770 million. So to sub a billion into P, we got to go how many millions is a billion? And the answer is 1,000 million is a billion. So we got to sub 1,000 in for P. Solve this for Y. So I get 1,000 equals 770 e to the power of 0.016 times y minus 1985. Little typo there, but it'll get fixed. Divide both sides by 770, and I get, well, I'm just going to cancel those zeros out, and I'm going to leave this as 100 over 77 because the decimal is nasty, so I want to keep it as exact as possible. So I'm going to keep it as 100 over 77. Now, instead of using log base 10 on both sides, I'm going to use ln on both sides, because anytime you have the ln of e, it just cancels out because it's a log base e of e. So it's that base rule that they cancel. So then we end up with ln of 100 over 77 equals 0.016 times y minus 1985. Divide both sides by 0.016. And so we get y minus 1985 equals ln of 100 over 77 divided by 0.016. Add 1985 to both sides of the equation. And now we should be able to punch this into our calculator and solve it for y. So we get y equals 2001.3. So if you actually go in, 2001.3 is probably around April 2001. If you actually Google when India crossed a million, it's actually relatively close. This formula that we're using here, I actually took out of an old textbook that I used when I was in school. So I'm dating myself a little, but it's old. It was before India crossed, and the formula is actually relatively accurate.